Hello everyone. Welcome to third SEM Diploma in Electrical and Electronics. One of the very important subject for you all in this semester is analog electronics. Before studying what is there in analog electronics, let us just have a look at the various gadgets which you must have seen in your grandparents' house. So this is the radio and the television. Look at the size of these devices of yesterday years. You must not have seen this computer, but olden days computers were of this size. How is the situation now? You all have the mobiles right now. So it's all in one. It can be your phone, it can be your computer, it can be your clock, alarm, stopwatch, TV, radio, camera, book, and so on. So, how did this transformation take place from huge devices to nano devices like this? All this credit goes to semiconductors, which forms the basis for the study of analog electronics. So in this course of analog electronics, in the first unit, you will be studying about semiconductors and diodes. What are semiconductors? What are the properties of semiconductors? Why is that we are studying the semiconductors? What are the products which are made? Diode is made from a semiconductor. What are the properties of diode, etc.? Very interesting. After studying this, we will be moving on to the second chapter, that is transistors and MOSFETs. These transistors and MOSFETs are used as electronic switches. You all have seen the mechanical switch in electronic circuits. Electronic switches, which are very fast, are used. So transistors and MOSFETs are used for that. It's also used as amplifiers. So when we speak in a mic, the loudspeaker, you hear your voice. So an amplifier amplifies weak signals. So after studying this transistors and MOSFETs, we'll be moving on to the third chapter, that is optoelectronic devices. What do you mean by opto? Opto means light. Electronic devices that are sensitive to light are called as optoelectronic devices. You have seen your remote control cars are there, your TV and the remote. So in the remote you'll be having IR transmitter which transmits infrared rays. In the TV you'll be having the sensors which takes up those rays and switches on the TV. Likewise your car, your toys, all this. So all these devices we'll be studying in the third chapter. Along with that your LED, LCD lights and all. After studying this, we'll be moving on to the fourth chapter, that is rectifiers, filters and regulators. Why are these required? Why is it you need to study this? See, the power is manufactured in the form of AC. In many applications, we need DC. So what do? First of all, we'll be using a transformer to reduce the magnitude of the alternating current. Next, we'll be using a diode which converts this alternating voltage to pulsating DC voltage. If you want a pure DC voltage like this, we'll be connecting it to a filter which removes those oscillations, but it becomes approximately equal to a DC voltage. When you use a voltage regulator, you get constant DC voltage. So in unit 4, you'll be studying about the different types of rectifiers, filters, regulators, etc. After studying this, we'll be moving on to the fifth chapter where we'll be studying amplifiers and oscillators. As I said earlier, amplifier increases the strength of weak signal, whereas an oscillator produces the oscillations which are very much required for synchronization of various devices. In the last chapter, that is operational amplifiers and timers, you will be having an understanding of what is an op-amp, which is basically used as for mathematical operations like addition, subtraction, integration, differentiation, etc. And also the timers, which are used for missing pulse detection, bounce free switches, touch switches, frequency divider, capacitance measurement, pulse width modulation, etc. Sounds interesting, right? Yes. Analog electronics is the fundamental subject for the electronic and electrical and electronic students. You will definitely have a very good understanding of this. Happy learning and thank you. Let us start our discussions about semiconductors in the next class.